Hello everybody, this is Miss Plekarski going over the review for your Unit 5 exam on on graphing rational functions without a calculator. Remember, for this exam you are not going to have a multiple choice test. It's going to be a fill in the blank, and you will have some answer box. So you'll have answer choices to choose from. Before we get started with the equations, let's go over our notes on how to find all the information you need to graph your rational functions. So first of all, to find your x-intercept, you set the numerator equal to 0 and solve for x. To find your y-intercept, you set x equal to 0 and you solve for y. So just in your equation, anything that is attached to an x, you can just kind of cross it out, and then you see what's left, and that's what your y value is going to be. All right, and then to find your vertical asymptote, you set your denominator equal to 0 and solve for x. Before I go on, guys, you might want to make sure you have all of this information that I'm going over right now on the index card that you can use on your test. All right, so to find the vertical asymptote, set the denominator equal to 0, solve for x. If you have more than one factor, you'll set both factors equal to 0 and solve for x. And then for your removable discontinuity, if you have the same number for both an x-intercept and a vertical asymptote, then you'll cross that number out, and it is going to become your removable discontinuity. All right, let's go on to a couple more pages of notes. All right, so to find your horizontal asymptote, you need to compare the degrees of your numerator and the denominator. Remember, your degree is the exponent. So if your numerator's degree is less than the denominator's degree, then the horizontal asymptote is always going to be at y equals 0. You won't have to calculate that or anything. That's just where the horizontal asymptote is. Now, if your numerator's degree is equal to the denominator's degree, then the horizontal asymptote is at the equation y equals whatever your leading coefficient is, in other words, the number in front of your x. So the leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay? And then if your numerator's degree is greater than the denominator's degree, then you do not have a horizontal asymptote, and instead you will have either slant, diagonal, oblique, or end behavior asymptote. Okay? And then to find your slant, diagonal, oblique, or end behavior asymptote, you're going to either use long division or synthetic division to find the equation of the asymptote. And with these, it'll be something like y equals mx plus b, or it'll be something like y equals some number x squared plus or minus some other number. Okay, so it's actually going to be an equation for your slant or end behavior asymptote. All right, so those are your notes. Let's go ahead and look at the some of the equations that we looked at in class. Sorry, kind of scatterbrained today. So we have two possible equations. Remember, on my tests, I always have several different versions, so you can't just write everything down for one of the equations and call it good. You have to know how to factor these, okay? And whenever you're graphing rational functions without a calculator, you always have to factor as much as you possibly can. In this case, we know that our numerator is just going to be x plus 2. That cannot factor anymore. And then for the denominator, we need two factors. On this one, you need two factors where the first terms will either be an x or a 5x. Okay? And then because I have a plus sign here, the signs for both of these factors will be the same. And because I have a plus sign here, they are both going to be a plus. So it'll be x plus some number and 5x plus some number. Now over here, same thing, I'm going to have a 5 and a 1, or just an x and a 5x. And then because I have a minus sign here, one of my factors will be negative and one will be positive. Initially, you might not know for sure which will be positive and which will be negative, but we'll show you in a little bit. It has to do with whatever your middle term is here. All right, so now remember, for the test, you will have an answer bank. So if you are totally lost on your factoring, make sure you remember how to know whether it's going to be plus and plus or plus and minus or minus and plus, okay? So once you think you know what two factors you're going to use, you always want to verify it. You can either multiply everything back together with the box method or FOIL method and make sure that when you box this or FOIL this, you're going to get this, or if you get box or FOIL this, you're going to get what you have up here. Specifically, your middle terms, you want to look at those. If you multiply these two terms together and these two terms together and then add your answers, you should get your term here. So in this case, we have 2 times 5x gives you a 10x, and an x times 1x gives you an x, so 10x plus 1x gives you an 11x. And then same thing over here, 2 times 5x gives you 10x, and an x times negative 1 gives you negative 1x. So 10x minus x gives you 9x. Okay, so we're just checking our middle terms. Also, your your number here times this number should equal this number here. Okay, so you should always check and verify that you have the right answer. Now in class, we did one of the equations from here, and I just let my students pick. In this video, we're going to do this equation, and we already know that this equation has these factors. Once we know that, we can go ahead and find our x-intercepts. We just set our numerator equal to 0 and solve for x. So here we get x equals negative 2. Okay, and then to find our vertical asymptotes, we set our denominator equal to 0. We're going to set, because we have two factors, we'll set each of these factors equal to 0 and solve for x. So we get x equals negative 2, and we get x equals 1 over 5. Okay. Now, it might help you to know that 1/5 is equal to 0.2. So on the test, we should have some scientific calculators to use. Okay. Notice that I have x equals negative 2 both for an x-intercept and a vertical asymptote. That is not possible, so I'm crossing those numbers out there. And then my removable discontinuity is going to be at x equals negative 2. Okay, let's look on the left side now. The degree of my numerator is a 1 and the degree of my denominator is 2. The relationship there is that the numerator's degree is less than the denominator's degree. So my horizontal asymptote is at y equals 0. Because I have a horizontal asymptote, I cannot have a I cannot have a slant or end behavior asymptote. And then I think I'm ready. Oh, wait, no, I need to find my y-intercept. Before I graph this, I need to know where my y-intercept is. And equals. For your y-intercept, x is going to equal 0. So anything that has an x in it is going to just disappear. So we have a 2 divided by 2. So your y-intercept is at negative 1. 2 divided by 2 is 1. Because of the negative sign here, you have a negative 1. So we know that our y-intercept is at negative 1. We do not have a x-intercept. We just have a vertical asymptote and a horizontal asymptote. So our horizontal asymptote is at x equals 0, or excuse me, y equals 0. And then the vertical asymptote is at 0.2. I'm going to try to draw this accurately with the mouse pad. It is not very easy to do. Okay, so there we go, and now we can go ahead and try to graph this. First of all, it's good to remember that if you have an intercept, it helps you tremendously to know whether you're above or below your horizontal asymptote. And in this case, I'm going to be, because my y-intercept is here, I'm going to be below it. And as I go to the right, I'm going to hug or follow the path of this asymptote here. And as I go to the left, I'm going to curve and go this way, over here. And then on this side of the graph, I could be above the horizontal asymptote or I could be below the horizontal asymptote. In class, I am showing the students how to use the bottom part of the test, this right here. To do that, you just list where your horizontal asymptote is. In this case, it's at y equals 0. And then you want to list your factors. So basically, any x-intercept you have, any vertical asymptote, and any removable discontinuity. In this case, we have x equals -2, and that's my slant asymptote. Hold on, is it negative or positive? Let me go back. It's positive 0.2. And then I have a removable discontinuity at -2. That's where I was getting a negative from. So the two factors, or the two key important values for x, are going to be at -2 here and at 0.2 here. And really, because my horizontal asymptote is at y equals 0, I just want to know, am I going to be above or below the horizontal asymptote? Now, because of the location of my y-intercept, I already know that this side is going to be below the horizontal asymptote, but I can always check. I can plug different values in. Let me grab my equation. Let me see. I want to copy that and paste it over here. So let me put my equation over here so we can see it and I don't have to keep moving back and forth. All right. So because of where my y-intercept is, I know on this side of the graph, I'm going to be below the horizontal asymptote. So I'm going to be kind of in this section here, right below it. But on this side, I'm not sure if I'm going to be below the horizontal asymptote or above the horizontal asymptote. Okay. So if my asymptote is at y equals 0, I need to know, is my answer going to be positive or negative? Okay. So what I can do is I can just pick any number that's in this section here, and I'm going to plug it in for x. In this case, I want to use 1 because it's in that section. So I have a 1 plus 2 gives me 3. And let's see, so I have a 1 here, so I have 5 times 1 is 5 plus 9, because 9 times 1 is just 9. So 5 plus 9 gives me 14, and a minus 2 gives me a 12. So it's a positive 12. And this is a 3 over 12, so it is going to be positive. So in this section, I am going to be above the horizontal asymptote as well. And it's good to know that no matter what number I had picked, if I had picked a 2 or a 4 or a 6 or any number in this section, I would still get a positive value. So because of this information, I know that this side of my graph is going to be above the horizontal asymptote. And because I know that my graph is going to follow the path of my asymptotes, it's not going to be too hard for me to guess what the graph looks like. So it's going to look something like this, where it's going to curve around here because of this asymptote, and it's going to curve around here because of this one. All right. So there is my first problem graphed without a calculator. So much fun. In class today, I did talk to my students about how using this part here may be a little bit confusing for you guys. You don't have to use it, but you can if you want to. Okay. All right, so the next problem, we have these two formulas, and again, we need to factor them. Okay. And, excuse me, it'll be interesting, or it'll help you if you remember to first figure out whether your signs are going to be negative or positive. And because you have ones here and here, the only possible number you can have for the second term is going to be a 1. Okay. In this case, with this, because we have -1 and -1, one of my terms is going to be positive, and one of my terms is going to have a minus or a negative. Okay. Same thing down here, a -1 and a +1. And yes, I know initially you're not going to be sure which one is going to have negative and positive. Over here, because I have a plus signs here, I know that both signs, or excuse me, both factors have to be the same sign, either both positive or both negative, because your middle term, because your middle term is negative, then you know that both of them have to have a minus sign. So in this case, because I want a 1 here, 1 times 1 is 1, so I'm going to have negative 1s in my factors. Okay. Now for the next part, you have a leading coefficient of 7. So you're going to have just two terms that you multiply together to get 7x squared. So in that case, a 1 and a 7 will give you 7x squared. And then a 1 and a 7 here as well. For the 6, it's not so readily apparent. You could have a 2 or a 3. Let me write that down. Okay, so you could have a 2 times a 3 to give you 6. That'll give you 6. Or you can have a 1 and a 6. 1 times 6 will also give you 6. But you need to ask yourself, how can you add these terms together and get a negative 5? And one of your terms needs to be negative and one needs to be positive because of the negative 1 here. So if you had a negative 2 and a positive 3, you wouldn't get a negative 5. If you had a negative 3 and a positive 2, you still wouldn't get negative 5. But if you had a negative 6 and a positive 1, then you would have negative 5 here. Okay? And then the same thing over here, you have a 6 here, so it's going to be either 1 and 6 or 2 and 3. And you need to have, both terms are going to be negative. We know that. Both terms will be negative. And then they add together to give you 7. Well, the only way to add those together, negative 7, would be to have a negative 1 and a negative 6. Okay? So it is fairly easy to factor. Even when you have some really what looks like complicated numbers, you should still be able to factor it. Okay? Especially remember, you are going to have an answer bank to choose from. All right, so for this one, we picked this equation to graph on or without a calculator, and we already know that those are our factors. So when we find our x-intercepts, we set the numerator equal to 0 and solve for x. So we have x equals a positive 1 and a negative 1/6. Okay. It will be helpful to know that negative 1/6 is approximately equal to, I think it's 0.16 repeating. Make sure I put the negative sign there. And then next, find your vertical asymptotes. So you'll have set both of these factors equal to 0 and solve for x. So from here we have x equals 1. And then we also have x equals negative 1/7. Okay. And then it will be good to know that negative 1/7 is equal to negative 1 or negative 0.14, I believe. Check your scientific calculator if you need to. Okay. So those are our x-intercepts and vertical asymptotes. And again, notice that you have the same number. Here you have a 1 here and a 1 here, so cross those out, and that's going to be your removable discontinuity, is that x equals 1. All right, and then let's go to the right side of the graph, or to the left side of the graph. So now our numerator's degree is 2 because of our exponent here, and our denominator's degree is 2 because of this exponent. And the relationship there is the numerator's degree is equal to the denominator's degree. Whenever you have that situation, you have to take your leading coefficients. So 6 divided by 7. So your horizontal asymptote is at y equals 6 over 7. And that is approximately equal to, if I remember correctly, 0.86, if I remember correctly. All right, so guys, you will have a scientific calculator, so if you have any weird fractions like this, you will be able to type them in the calculator and find out that they're 0.86. All right, Let's see. Oh, we still need our y-intercept. So in this case, our y-intercept is at y equals +1. For your y-intercepts, just get rid of, whoops, there. You want to get rid of anything that has an x in it. So if you feel like scribbling it out, you can. So your y-intercept is at -1/-1, which reduces to 1. There. Because we have a horizontal asymptote, we will not have a slant or end behavior asymptote. Let's go ahead and label what we've got. So we have a y-intercept at 1 and a slant asymptote at -0.16. Okay, did I say slant asymptote? An X-intercept, excuse me. I have an X-intercept at -0.16 there. And then let's go ahead and label our asymptotes. So at +0.86 is our horizontal asymptote. And then our vertical asymptote is at -0.14. So it's really, really tight right here. We've got a lot of stuff going on really close to the x-axis. Okay. The cool thing is, for those of you that absolutely hate using this bottom part, is for this type of equation, you really don't need it because you have a vertical asymptote up here, and we know that there's, did I say vertical asymptote? Ignore what I say. Listen to what I mean to say, not what I actually say. I meant to say we have a y-intercept right here. So I know that this part of the graph is going to just kind of hug this asymptote right here. Okay, and then this part of the graph is going to hug this asymptote. We're going to get really close and friendly with that asymptote. And then over here, because of my x-intercepts down here, I know that I'm going to be on the bottom part. Pretend this is a straight line. Just use your imagination. It's a straight line. Okay, and it's going to go down here as well. All right, so your graph is going to look something like that. Holy crap, I totally forgot about my removable discontinuity for this problem and the other problem. So really quick, I have removable discontinuity at x equals 1. So to label that, you need to draw an open circle on your graph line when x is 1. And I need to go back to my previous graph right here because I forgot about the removable discontinuity at x equals -2. So I need to draw an open circle right there. Alrighty, please, please, please do not forget about your removable discontinuity. If you don't draw it on your graph, I will take off points. Alright, so that's another one that we did. Excuse me. Let's see, what else do I want to say? Alright, hopefully you're good with this one. Let's go ahead and look at our next problem situations. Okay, this time we have our equations are much more complicated. We have a cubic function in the numerator, linear function in the denominator. Again, we still need to factor as much as we can. With this type of problem, whenever you have something like that, see if you can group your terms. In this case, you're going to group, what did I do? Oh, there we go. I skipped a step somewhere. I did. All right. Let me go ahead and get rid of this, and then I'll show you how I group these. And I'm going to change my pen color to, oh, they don't have purple. We'll do pink. Pink is close to purple, right? All right. So in order to group this, we break this down into these two sections, okay? And then you're going to look at this section and say, okay, what do both of these terms have? And we'll both have an x squared. So you can factor out an x squared here, and you're left with x plus 6 here. And then look at these two sections and see what you can factor out. In this case, we can factor out a negative 25. So you have negative 25, and then you're left with x. Negative 150 divided by negative 25, believe it or not, is a positive 6. Okay. Notice that this factor is equal to this factor. So now, on both of these terms, I can factor out an x plus 6, and I'm left with the factors x plus 6 times x squared minus 25. Okay. I just did x squared and then the minus 25 here. Okay. Now in your numerator, in the denominator, you're just stuck with x minus 4. You can't factor that anymore. The denominator, sorry. So in your numerator, I'm confusing denominator and numerator. Sorry. So the denominators are all going to just be x minus 4, and for both of these equations. Okay. You can't factor the denominator anymore. In this case over here, let's look back over here. This is factored as much as it can be, so that's just going to stay x plus 6. Right here you have x squared minus 25. Well, you can factor that in as a difference of squares. Oops. And you end up with x minus 5 times x plus 5. Okay. Same basic thing over here. Notice what you are starting out, there's not a huge difference here. The main difference is when you are grouping them. Okay. You have really just this sign here is different and this sign here is different. So now if you factor that, you get x squared equals x and a minus 6. And then over here you have a negative 25. Factor out a negative 25 and you get an x. And in this case, because you have a plus here, if you divide it by a negative number, so positive 150 divided by negative 25, it's going to become negative 6 here. Okay. So your factors are going to be x minus 6 and x squared minus 25. Your x minus 6 cannot factor anymore, but the x squared minus 25 will factor to x minus 5 times x plus 5. Okay. If you want to check, you can always multiply everything back together here and make sure you get what you have up here. All right. On the review, we are going to go ahead and graph this equation without using your calculator, and we already know that this equation's factors are these right here. So let's figure out our x-intercepts. Again, you're going to set each factor equal to 0 and solve for x. So in this case, we have x-intercepts at negative 6, at positive 5, and at negative 5. So there's 3 x-intercepts there. To find the vertical asymptotes, we set our denominator equal to 0 and solve for x. So in this case, we have a vertical asymptote at x equals 4. Because none of these numbers here and here are the same number, we are going to have no removable discontinuity. Okay, let's look at the left side here. Our degree here is 3. Our degree here is 1. So in this case, your numerator's degree is greater than your denominator's degree. Anytime that's the case, you do not have horizontal asymptote. You're going to have a slant or end behavior asymptote. In order to find that, you have to do either synthetic division or long division. Okay. In this case, because I have a very simple denominator here, I just have a coefficient of 1 here and an exponent of 1 here. So I can do synthetic division. To find the number that goes in your corner box, you have to set this equation equal to 0 and solve for x. When you do that, you get x equals positive 4. So on this equation, because I can do synthetic division, I'm going to go ahead and do it. So I'm putting a 4 in my little corner box. My coefficients are going to be 1, 6, negative 25, and negative 150. So let's do 1, a 6, negative 25, and a negative 150. Okay, we're going to go ahead and do synthetic division. Drop down the 1, so 4 times 1 is 4. We're going to add these two terms, gives you 10. Okay, 4 times 10 is 40. Oh man, I've got to add this together. So let's see. Negative 25 plus 40, let's see. That'll be a 5. Is it 15? Let's see, 3, 40. Yep, a positive 15. 15 times 4. Oh my goodness, this is really challenging my mental math. See, that would be 20 and then 60 there, right? And then, so my final number is going to be a negative 90. Okay, this is a big number, but honestly, I don't care about this number. I care about these terms here. This is my remainder. I don't care about it at all. Hold on. Okay, I just want these terms here. So my equation is going to be f of x or my y value. Y equals either one. You can do f of x or y equals. Both work. This is my constant term. So my final number will be a plus 15. And then this is going to be multiplied by x. And then this one's going to be multiplied by x squared. So I will have x squared plus 10x plus 15. Okay. Let me see. So let's go back up. We have y equals, or f of x equals x squared, if I remember correctly, plus 10x plus 15. I'm going to have to go back and check that. Whoops. Yep, plus 15. All right, so there's all the information. Now I need to go ahead and plug this stuff into my graph and graph it. Let's see. Oh, dang it. I forgot my Y-intercept again. You don't want to forget the Y-intercept. It will help you tremendously. All right, Y-intercept is at y equals what? So if I get rid of this and I get rid of this, I'm left with negative 150 over 4, or excuse me, over negative 4, so it's going to be a positive number. 15 divided by 4 is 3, and let me see. That'll give me 12, 30, so that remainder of 30. 30 divided by 4 is, man, this is killing me on mental math. Let's see, a 7, and I'm going to have a 2 left over. I will go ahead and do that as 37.5. Notice that my scale here is 6 to negative 6 and negative 8 to 7. That's not going to work for me to be able to actually see my X-intercept and my, or sorry, I will see my X-intercepts, but I'm not going to see my Y-intercepts. So, and chances are I'm probably not going to see a lot of my graph. So I need to change my window. I will tell you on the test, I will tell you on the test what your window parameters are. So you don't have to worry about trying to figure out what the window parameters need to be. All right, so with this one, if my Y-intercept is at 37, I need to have at least probably 50. So if I did 10, 20, 30, 40, 50, that would probably give me an accurate graph. So I do a 50 here, which means I have a negative 50 here, negative 10, 20, 30, 40, 50. So each of these tick marks has a scale of 10. Now my X-intercepts are at negative 6, 5, and negative 5. and my y-intercept is, or sorry, my vertical asymptote is at 4. So these will actually probably work here. So let me get, nope, I can't. So I'm going to go ahead and leave this as a scale of 1. So 1, 2, 3, 4, 5, 6, 7, 8. So this is -8 here. 1, 2, 3, 4, 5, 6, 7. This is a +7 here. I'm going to go ahead and leave the X scale as it is. The Y scale is the only thing I changed. All right, so let's go ahead and get graphing. My y-intercept is at 37.5, so 10, 20, 30, excuse me, about right there is my y-intercept. X-intercepts at -6, so right here. At -5, right here, and then +5. 1, 2, 3, 4, 5, right here. Okay. I have a vertical asymptote at 4. And I will tell you, figuring out your graph for your end behavior asymptote is going to be kind of interesting. Okay, so we know that the end behavior asymptote is at y equals x squared plus 10x plus 15. I will tell you, when you try to draw that on here, it's going to be really, really complicated trying to graph it without a graphing calculator. So in this case, what I'm going to do when you get to the problems with end behavior asymptotes, I will have pictures of possible asymptote and behavior asymptotes for you, and you can copy them on your paper. Okay, so let's look at our graph that I graphed. Let's see. So here we go. Here's our graph, and it looks like this. Okay, so we're going to have a intercept here, here, and it's going to kind of go like this. Okay, let's see if I can duplicate it super quickly. All right, so let's see, at -6. So something that looks like that. All right. Again, on the end behavior asymptotes, I'm not going to be super critical. Just get it kind of the basic shape. I will have pictures of possible graphs for you if you can, pick from 4 or 5 and say, hey, this is definitely my asymptote, then you'll be good. All right, so let's go ahead and graph this now. Let's see. All right, I need to change that to blue. We have an asymptote, or sorry, we have intersects here, here, and here. So this part of the graph is fairly easy, and we know that it's going to follow the path of this asymptote in red. So you can just kind of sketch your graph like that. Okay. This side of the graph is kind of ambiguous. We're not sure, is it going to be going up? Is it going to be going down? What? So on this side of the graph, it will help to use the bottom portion of your line. Now this asymptote here is not going to affect this side of the graph a whole lot because of this asymptote here. So let's find out if when we are between these 2 points, are we going to be negative or positive here? So we have, let's see, this asymptote, or sorry, this intersect is at 4. So if you plug in a 3.5 in here, so you'd have 3.5 here gives you a positive, negative, and positive. So your numerator would be negative, and then 3.5 down here would also be negative. 3.5 minus 4 gives you a -0.5. So you have a negative divided by a negative, so you're going to have a positive. So between here and this asymptote, you're going to be above the x-axis. So your graph is going to go like this, okay? But what happens over here, so pick a number that's in this section, so a 6 or a 7. If x was 6, you would have a positive value here, positive here, and positive here, and positive down here. So you're also going to be going up on this side as well. So your graph may look something like this, okay? Whoa, that's crazy. Let me fix that. All right. So most likely what the graph looks like is something like that. Kind of crazy. All right. So this one's the end behavior. Honestly, I may toy with letting you use your graphing calculator for the end behavior. Most likely not. Most likely I will show you pictures and you will have to pick of the pictures that you have available which one has the same vertical asymptotes, X-intercepts, and then the formula for this slant or end behavior asymptote. Okay, let's move on to our next problem. Let's see, we're not doing that. Okay, for this one, lots of different options here. I will tell you, because of interest of time, it's getting really late. This is a long video. I'm just going to uncover all of your factors, and then we'll talk about how we got them. Again, remember, whenever you're graphing rational functions, you always want to factor them as much as possible. Okay, so notice that my numerator and my denominator is factored slightly. And, okay, so right here, notice for the denominator, you have 3x plus 12 for all of your denominators. And because both terms are divisible by 3, you can factor out a 3 and you get x plus 4 here. Okay, right here you have a plus sign here, so both terms need to have the same sign. We have a minus here, so both of them are going to be negative. Down here you have a plus sign here, so the same sign, but this one is positive, so both of these factors will have plus signs. Over here you have a negative, so one will be a positive and one's a negative. Because you have a positive 2 here, your 3 or your larger number is going to be positive and your smaller number is negative. And then down here you have a negative here, so negative and a positive. Because you have a negative 2 instead of a positive 2, your 3 is going to be negative and your 1 is positive. Okay. I know that was a very quick review of factoring. Hopefully it'll help you. Let's move on. In this case, we're going to graph this equation. We already know that these are the factors. So to find your x-intercept, you're going to set your numerator equal to 0, or set both factors equal to 0 and solve for x. So you have x-intercepts at -1 and -3. Okay. And then for this one, you set this factor equal to 0 and solve for x. Honestly, you can just ignore this 3, okay? Does not matter. It's not going to change the location of your vertical asymptote. So in this case, your vertical asymptote is at x equals -4, okay? We will not have any removable discontinuity since we do not have any of the same numbers here. Our numerator's degree is 2. Our denominator's degree is 1. Your numerator's degree is greater than the denominator's degree, so we will not have a horizontal asymptote. We will have slant or end behavior asymptote. And again, to find that, you do either long division or synthetic division. So I need a new page to do that. Okay. On the graph, so we have to do long division. We cannot do synthetic division because of this 3 here. It won't give us the correct answer. So let's just do long division. We have 3x plus 12 here. And pretend that's a straight line. Man, I need to do a better line. There we go. and we are dividing x squared plus 4x plus 3 by 3x plus 12. So you need to ask yourself, what do you need to multiply 3x by to get x squared? Well, first, to get rid of that 3, we're going to divide by 3. And then to get x squared, we have to multiply by x. So now we tell ourselves, okay, what is 1/3 x times 3x? And that's just going to leave us with x squared. And then what is 1/3 x times 12? That's going to end up being 4x. Okay, remember when you're doing long division, you have to subtract here or switch the signs. So those cancel out. You get a 0 and a 0. Your 3 carries down, and this is going to end up being your remainder. So the equation for your asymptote is going to be y equals 1/3 x. Okay, for your slant, and this is going to end up being a slant or diagonal asymptote, y equals 1/3 x. I will tell you these ones are going to be much easier to graph. Oh, we forgot about our y-intercept again. Okay, where is the y-intercept? It is going to be at 3/12 or 1/4. Okay, so with this y-intercept, it looks like we can leave the scale alone. So our y-intercept is approximately right there. Our x-intercept is at -1 and at -3. Okay, and our vertical asymptote is at -4. Let me do that with a red line. Okay, now to graph your slant asymptote, your y-intercept, when x is 0, your y is going to be 0, so you're going to start at the origin, and then hopefully most of you remember how to graph linear equations. It's just rise over run. So you're going to go up 1 over 3, up 1 over 3. Okay, up 1, I'm running out of space here, so now I'm going to go down 1 over 3, down 1 over 3, down 1 over 3, and again I'm running out of space, so approximately right here. Go ahead and add a couple extra dashes for this asymptote. Okay, so now that's what I have on my graph. The cool thing is, because of all these intercepts, I know that this section of the graph is going to be up top, and I know that it's still going to follow your asymptote. So here it's going to go like this, and we're going to go down and then up, and then it's going to follow this asymptote here. Okay. Over here, I'm not sure exactly if I'm going to be down here or up here. It could be either one. So I'm going to pick a number that's on this side and plug it in for x. So if x is -5, what will I get? I will tell you when you're doing that, it'll be easier if you plug it in here. So I have a -5 plus 1. That's supposed to be a 1 there. And a -5 plus 3. So in the numerator, I have, let's see, -4 times -2, which will give me a +8. And then -5 plus 4 gives me -1. -1 times 3 is just a -3. And most of you know, or you can plug in your scientific calculator, you can plug that in and you get, let's see, 2.6, is that right? 2.6 repeating. Oh, I forgot my negative sign, -2.6. So when x is -5, my y value is -2.6, so about right here. Because I'm down here, I know I'm going to follow this asymptote here, and I'm going to curve around and then follow that asymptote there. Okay, so there I've graphed my slant asymptote. I did need to do long division for that, so that was the tough part, but honestly you really don't need this part. You can, if you want to, just list the x-intercepts, y-intercepts, and then the equation for your slant asymptote. Honestly, this part is a little bit difficult. I would not suggest trying to use it. Okay, that's the end of the review. Please, please, please make sure you remember how to factor. Okay, fill in your index card with all the notes that we covered at the very beginning. Where are they? All of these notes about how to find all this stuff, and be ready for your test on Wednesday. Bye.